So in this video, I'm going to be running through the process on how to build your own Bitcoin hardware wallet that will be running the same open source software that you find running on a Blockstream Jade. The number of reasons why people might want a DIY device as opposed to one they just buy through retail, and I've talked about that in the past when I've looked at other videos for various open source wallet projects. And if you haven't already done so, hit subscribe, and that way you can stay in the loop for content I make to help you find your way in the crazy and often hostile environment that is cryptocurrency. So this is definitely going to be a longer video and one of those ones where you might want to skip to the parts that interest you. First things first, I'm just going to run through some of the different hardware options that I'll be looking at in this video. Secondly, I'll be running through how to set up your installation environment and flash some firmware in Linux. Then I'll be running through how to set up your installation environment and flash in Windows. And then I'll also be running through some things you want to do to sort of secure your device, including running through how to enable secure boot, and then finishing up with a bit of a conclusion. So let's have a look at the hardware. So these are the three devices that I'll be looking at in this video. And the important thing to note is that none of these require any assembly. You pretty much buy them all and can use them exactly as you get them. Now, the downside of that is none of these actually have a camera on them. They can all just be used with Bluetooth and USB only. Now, I do have some hardware that should give us the camera functionality just on the way, but that will be in a future video, and that will require a little bit more assembly than this video, where everything just works straight off the shelf. If you are trying to work out which hardware to buy, I've put a bit of a summary on my GitHub for all of the different hardware options that I look at in this video, as well as the Fire, which I don't have a sample for here right now. But the quick summary is this, which is that these two devices here actually implement all of the features that you would see on a retail Jade, like all the basic stuff like USB connectors, battery, monitoring, and all that sort of stuff all works fine. The grey at the bottom of the screen there is where I just damaged it, so ignore that. You can also get a case for this one on the end here. It doesn't just have to be a raw PCB, but that didn't really arrive in time for this video. But the price of these are 10 USD, 20 USD, and 40 USD respectively. And the other thing that's important to say is I've actually enabled secure boot on all three of these devices, meaning that these two devices are at least as secure as a retail Blockstream Jade. So currently the M5 Stick C only supports secure boot version 1, not version 2. So this one here is actually not quite as secure as these ones or as a retail Jade. Personally, I feel like the M5 Stick C is hard to beat just in terms of the size and the cost and the functionality. One issue with the M5 Stick C is that it has a different device ID to the other M5 Stack devices and to the retail Jade, which means that it won't automatically get picked up by wallets like Sparrow, Electrum, or the desktop wallet when you plug it in via USB. Adding the device ID into things like Electrum and HWI is quite trivial. Again, I'll be bringing pull requests for that, but frankly, who knows how long that will actually take to get incorporated into the official releases for those softwares. It works brilliantly over Bluetooth using the Blockstream Green app. And works great if you're happy to substitute your own executable for HWI or roll your own for Electrum. Neither the Liligo or the M5 Stack device actually have that problem, so if you're looking for something that just works straight off the shelf with all existing Jade software, is portable, has a battery and a nice case, the M5 Stack device is probably your best bet, or maybe the Fire for 10 bucks more. The Fire is most likely to work better with an add-on camera that you could stack onto the base of it, but no promises, that will come later. Alright, so now I'm just going to pretty much run through following the existing documentation from the Blockstream GitHub repo, just using a fresh install of Ubuntu 22.04. Firstly, we'll just head over to the Jade GitHub repo, and if we scroll down, it actually has some instructions on how to do this. And we'll just actually do it manually rather than using Docker. So we're going to have to open up a terminal. And before we do anything else, there's actually a few packages we're going to have to install. So we'll do sudo apt update just to make sure that our system has the latest list of packages. Okay, so now we'll do sudo apt install, and we need git, we need python 3 pip, and we need python 3 venv. And none of those three things come default with Ubuntu if you've gone for a minimal install. So say yes. So the other thing we have to do is notice the first command here actually changes folder to a folder called ESP. So we'll just make that folder. So we'll say mkdir ESP. Okay, now we are good to go. So what we can do is we can actually just copy that whole block, and we can just right click and just paste and hit enter, and it'll do all those things all together. So again, this will take a while. So basically now we can just run this command here, which is the same as the one that it is actually just telling us to run anyway. There we go, and we are now ready to build. So what we're going to do now is we are going to get the firmware. So we're going to go back to our home folder. So we'll just type in cd tilde and then enter. Now this block of text here will actually go all the way to flash the device. So what we're going to do is we'll just start with these 2 lines here just to check out the repository for the firmware, and then I'll actually just change these commands based on the hardware that I've got, and then we'll try and flash it. So let's just get the Jade repository downloaded. Okay, now that is checked out. Now this next command here is going to be different depending on the hardware you've got. This is just the M5 stack basic, and if we open the box, it's got a bunch of jumper cables, we don't need those. It's got a micro USB-C cable, got tons of those already, and this is the actual device itself. So if we jump back over to here, the config file we want is actually, we'll just use the file explorer for this. We can actually see, so here's that ESP folder that we put all of the build tools into. Here's Jade, that's the repository. So these files in here are all the same as the ones now that you would see in here. This command here, what it's basically doing is copying a set of configuration from this configs folder into the main home folder for the Jade repository, and that's the configuration it's going to use to sort of build and flash. In our situation, we're actually going to use this one here, SDK config display M5 black or grey. That's the one we want for this basic device here. So we're just going to copy that, and we're just going to paste it into the repository folder, and we're just going to rename it to be sdkconfig.defaults. So we'll just get rid of that middle bit. So what we've actually done here is just use the graphical interface to do the same thing that this command here would do. So basically what we're going to do is we'll just plug this device in. There we go, M5 stack. So that's just the default firmware that comes with it. I'm doing this on a virtual machine, so I'll just plug that in. Over here on Linux, if I just type in sudo d-mesg and hit enter, you'll actually see it has connected the device, and it is actually these devices appear as a serial device, USB to serial device, and that's it there, TTY ACM0. So that's good, it's showed up and we're ready to go. So we should now just be able to do this, build and flash the firmware, idf.py flash monitor, and with any luck it will actually just work. Oh, CMake must be available. Hang on, so let's just install that. Okay, let's try again. Hopefully this time it will just work. So this is just that command, enter. Ah, yes, okay. So the reason why it's giving this output here is that in Linux you also need to give permissions. You need to grant permissions for it to be able to use that command, so to use that port. Now at this point, if you're planning to use the device in Linux long term, your best bet is just to add the udev rules so that it automatically gets the permissions it needs when it's plugged in. However, if you're just trying to flash the firmware in Linux, you don't plan to use it in that space long term, we can get away with just using a command to set the permissions we need for the device just for this one time. So we'll just do sudo chmod. So we're going to change the permissions for the file. They'll all reset next time the device is connected, but we'll just do that. And now we'll run it again. And this time it should just work. There we go. So this is running now. And we can actually see it's actually running in monitor mode, which means it's currently outputting debug information to the console as well. So there we go. Okay, so that was the process of setting up the M5 Stack Basic, just following the process almost exactly from the official Blockstream repository. And what I'm going to do now is actually just run through how to set up the development environment and how to flash one of these DIY devices using Windows. And I'll be demonstrating that with the M5 Stick C Plus. And just as a quick note, I'll actually be using my GitHub repository, not the official Blockstream one. I have opened a pull request for the official repo that includes the functionality for the M5 Stick C Plus, as well as some fixes to the glitchy buttons with the M5 Stack Basic, but who knows when or if that will actually get merged. Alright, so we've got a fresh install of Windows here, so we'll just open up the browser. And look, just like before, we'll start off at the official Blockstream repository. And we're just going to scroll down to this bit where it says set up the environment. And we're just going to actually go to the Espressif official guide. And if we just scroll down towards the bottom, we'll find the manual installation for Windows. So we'll just click on that. And we'll just install the Windows installer. And look, we'll just use this one at the top here, Universal Online Installer, and that'll just download what we need. And there we go. So once that's done, we'll just open that. There we go. And we'll pretty much just follow the bouncing ball through the installer. Accept, yep. And if it suggests any fixes, it's probably a good idea just say apply fixes. So we'll say yep. We'll say next. If you don't already have all these tools installed, we'll just say we're going to download ESP IDF. Now, in terms of the version we want to install, this screen will likely change in the future. So my suggestion is that you actually go back to the official documentation on the Blockstream GitHub. And if you have a look at the commands for installing and setting up the environment, you can see that here we're being told to install version 5.01. So you pretty much want to make sure your version matches the one that they are suggesting, just to make sure everything works exactly as it should. In this case, that is the most recent version, so we can just say next. We can just stick with the defaults unless you want to install it somewhere else. And your best bet is just to leave it at full installation. That installs pretty much everything you need for all the different chips that it could use. It includes all the USB drivers as well as some helpful shortcuts for working in this development environment. So we'll just leave that as full installation and just say next, and then we'll say install. And basically here we're going to go and get a coffee because it's going to download about 1 GB worth of stuff. Okie dokie, and that's done. We'll just say finish. Okay, and then once that is finished, you'll see we have two shells here that are actually the same. One is just PowerShell and one is just old school Windows command prompt. And if we just close them, like say you accidentally close one of them, you'll see it's also probably created shortcuts on your desktop. And if you go into your start menu, there'll also be these ESP-IDF shells. So we'll just stick with the ESP-IDF CMD. And there we go. So this is our full working environment. And what we can do now is if we go back to GitHub. Now at this point, I'll actually be downloading from my repository, but you may find that by the time you watch this, this pull request that I've got here may have actually been merged, so you could just stick with the Blockstream repository even for the M5 Stick C+. My repository, we're going to go to code and we're going to say copy. And now we're going to go back into this command prompt that we had and we're going to type in git clone. We're also going to add recursive because we need to make sure it pulls all the submodules correctly. And then we're just going to right click and just say, and that will paste the thing that we copied, and then we'll hit enter. And that will just download it all into a folder called Jade. And now that's done, we can just do cd space Jade. And that will take us to the Jade folder. Now, I'll just quickly show you where this can be found in Windows Explorer. So if we just select this path down the bottom here, and then I'll right click and that'll copy it. And if I just go down and open File Explorer, and just click up here where it says Quick Access, where you put the path, and just paste that command and hit enter, what we can see here is all of the files that were in the GitHub repository. This is just the same as what it looked like in Linux, except we can view it all graphically. And what we're going to do now is we're going to go into configs, and we are just going to copy the default sort of development template for the M5 Stick C+. So we'll just say copy, and then we'll go back into Jade, and then we'll just click on the white space out here and just say paste. And we can see that has put the file down here. So I'm just going to rename that now to SDK config defaults and hit enter. And what we can do now is we can actually just go here and run a very similar command to what we used before to flash the firmware. Now, the one issue with the M5 Stick C+ is that it doesn't support the default baud rates that this ESP-IDF uses. So we actually need to force a specific baud rate when we are flashing the device. So we're going to copy this command with that extra B bit in it, and we are just going to paste that in there. At this point, we also want to get our M5 Stick C, and we'll plug that in. And from here, we can just hit enter. And now we wait. Oh yes, I forgot about this one. This error is an absolute pain in the bum. So basically what this error is showing us is that if we type in Python 3, for example, it will actually open up the Microsoft Store by default. We need to fix something up in Python. So in this case, I just stuck with the defaults, which installed it to C Expressive. So I'm just going to right click on that, and I'm just going to open up File Explorer again. And I'm just going to paste that folder in up here. And what we can see in there is there'll be a folder called Python_env. And this basically is the Python environment that it just installed for us. So if we go into scripts, we should find, there it is. So there's a Python executable right there. So all we're going to do in this case is just copy it and make a copy with a different name. So we're just going to copy and then paste, Control C and Control V, and we're just going to rename that one there to Python 3 and hit enter. So now, regardless, we'll just clear that. So now regardless of whether you type in Python or Python 3, it will find Python, whereas before Python 3 didn't work. So now we can run that command again, and this time it should just work. And there we go. We're in business. What we're going to run through now is what you want to do to actually sort of lock the device down a little bit if you plan on using it. Basically turning off some of the sort of debugging and development features that are in there and turning on some of the enhanced security features that are offered by this MCU. And for that, I'll be using the TTGO T-Display. So I'll be using Windows for this one, but the process on Linux is identical. All right, so this is all the source code that I just used to build for the M5 Stick C. And what we're going to do is we're going to go into the configs folder. And in this instance, we're going to copy this TTGO display file. So I'll just copy that, Control C, and I'll just paste that into the main folder. And you can see down here now there are 3 files called SDKconfig. So this one here is the one that I previously used for the M5 Stick C. So we're just going to delete that because we don't want it for this. And we're also going to delete this SDKconfig file here. It's very important you delete this file because essentially it still contains all of the settings that we used for the M5 Stick C. And now what we'll do is we'll just rename this file back to sdkconfig.defaults. So there we go. Now, and if I were to hit build right now, it would just flash this onto the TTGO display just like the other 2 devices. But before we do that, we're actually going to modify this so that it's more suitable for production. And I just want to quickly show you the difference between these config files we find in here, which are mostly with development sort of features, and some of these config files we find in this folder called production. And I've actually just got these files side by side here for the Jade 1.1. So you can see there's a chunk here for enabling secure boot, some stuff here for turning off debug features, something else relating to virtual eFuses, which is a development setting, disabling the console, that's a security setting, turning off all the logging, and that's pretty much the only difference. But I'll just run through the commands that we want. So we'll just go back here into that folder, and this sdkconfig.defaults file that we just copied in there, we're just going to open that just in whatever your text editor is of choice. I'll just use Notepad++. So the first thing we're going to do is just edit this file to basically make the changes that you need, just at a minimum. So you're not pretty much running a device with all development and debugging features turned on. One of the first settings that you want to add on is this one here. So basically what we're doing with config_log_default level none, why, is we are disabling the logging, where it's logging everything else out of the console. We can just stick them anywhere in this file, the top is just fine. And the thing that we want to remove is if we just do a quick, text search for config_debug mode, there it is, equals Y, we want to get rid of that because basically there are some functions in there for the wallet that allow you to do things that only make sense for debugging. You really don't want that enabled for a device you plan to use. And then once we've done that, we just hit save. And from there, the process of building it is the same as before. And we'll just plug that in. Okay, so now we just do our rdf.py flash, then monitor, and then hit enter. And now we just wait for it to build and flash. All right, and there we go. And actually, you can see here the difference straight away between this firmware and the previous one. In the previous videos, you would notice that the console over here was just sort of spamming all sorts of diagnostic information about this one, whereas this one is not dumping any of that out to the PC at all. It's just sitting there silently, and we won't see anything appear in this monitor screen. I've actually put some configuration templates with the debugging and developer features disabled just on my GitHub, just under the DIY folder in the repository. This may get moved or reorganized a little bit if and when it's merged into the main Blockstream repo. Now, the next thing I'm going to run through is how you actually enable and use this device with Secure Boot enabled. Now, the thing with Secure Boot is that once you turn it on, the device will only accept firmware that has been signed by the signing key. And if we go over to the expressive documentation on Secure Boot, it's actually very good. Now, rather than using menu config to sort of manually do steps 1 through 5 of this process, I've actually got some configuration templates just on my GitHub repository, just like the no debug ones for sort of the 4 main DIY platforms that I've got here. So you should pretty much be able to use these just as is. The only thing you might need to edit is the name of the signing key that it is looking for. But by default, they look for a signing key that is one folder above the repository folder. All right, so we're going to go back into the repository folder, and we're just going to delete these 2 files, just so we don't have any settings there from previous devices or builds. And I'm just going to grab the Secure Boot config. I'll be using this one for the video simply because I forgot to hit record when I actually flashed Secure Boot onto this. Process will be the same as long as you select the right profile for your hardware. So basically, I'm just going to copy that file and just stick it in the Jade folder where the others were. Paste that there, and I'll just rename that there to sdkconfig.defaults. Okay, so now we're going to generate our signing keys, and look, just because it's a DIY project, we'll just use espsecure.py that comes bundled with the toolchain for this. It should be just fine running it on a modern operating system, though if you are paranoid, you could also just use OpenSSL. But anyway, we're going to use a command just like this one. So basically, we'll just run that there. Now, we want to actually use Secure Boot version 2, so we need a key for version 2 because the ones between version 1 and 2 are different. And the configuration templates that I've got bundled on my GitHub look for a signing key just in the parent folder, so it's one folder above where the repository lives, and they're just looking for Jade DIY v2.pem. So if I just hit enter, there we go, it has generated that signing key. Once you've turned on Secure Boot and you have a specific signing key, the device will not accept firmware that is not signed by that key. So if you lose this signing key, you won't be able to push any more firmware updates to your device. You have been warned. Okay, so we've actually generated our signing key. So what we're going to do now is we are going to generate the bootloader just using the command they give us. So I'll just paste that in there, hit enter. And we can see here that it can say the bootloader is built, but because Secure Boot is enabled, it has not flashed it for us automatically. But it has just given us a command that we can actually just copy and paste to do exactly that. So we'll just select that command. We'll just right click and say copy. And look, I'll just paste that straight down here. Now we're just going to edit this just to take out the reference to the port and the baud rate, just because we've only got one device plugged in, and in Windows it'll automatically pick it up just fine. So we'll just hit enter. Okay, so this now is running a Secure Boot enabled bootloader, but it's not going to actually boot. You can see it says just staying in bootloader. So now we need to build the app, just like it tells us up here, because we hadn't actually done that yet. So we'll just say idf.py build, and we'll just hit enter. And just like before, you can see it's actually giving us a command. If you look closely at that, you'll see there's actually 2 commands here. It says, you know, do the top one or run. So what we'll do is, look, we'll just go for this top one, which will flash the signed binary onto here. Forgot to get rid of the port. And then we hit enter. And we can see here that it's actually done and it's staying in the bootloader because it doesn't actually do the encryption until you properly boot it for the first time. So what we're going to do is I'm going to say idf.py monitor, which is going to kick it off. And there we go. So this is now running the full Secure Boot firmware. And if we go into Blockstream Green, we can actually see that it is no longer categorized as a developer device, but is just a normal device. So there we go. If you're someone who's got a device with a version 1 ESP32 chip in it, it'll build, but when we go to flash it, we'll actually get this message here saying that the chip version 3 is required, whereas we can see here it's actually identified that this particular chip is a version 1 device. The process is pretty much the same, but you'll have to use Secure Boot version 1, not version 2, and I'll just quickly show you the difference there. So if you get that issue, pretty much just come back, delete sdk.config, and we're going to need to change this to, up the top, you have to change this from requiring level 3 to simply requiring level 1. And we're also going to need a new signing key for this, because the signing keys for V1 and V2 are actually different. So look, we'll just type V1 there, and we're actually going to have to generate a new signing key. So we'll just say save. We'll come out here, and what we'll do is now we're just going to use the same command to generate a new signing key. And we'll just call it DIYJade v1.pem, hit enter, and there we go. So it's actually made a new key. And once we've made these changes, the rest of the process is exactly the same as I previously showed you for Secure Boot v2. There we go. And now that has just taken a minute and it is ready to roll. So now this device has Secure Boot enabled. Now it's important to say, even though the implementation of Secure Boot found on these version 1 devices is susceptible to people doing fault injection attacks onto it, so physically removing the chip from the board, putting in specialized hardware and glitching it, Secure Boot, both versions 1 and 2, dramatically improve the physical security of the device, meaning that the level of sophistication that someone would have to be able to essentially gain access to the encrypted flash on the device, or with version 1 to be able to tamper with the software running on the device is much higher than if you had all of these Secure Boot features turned off. The simple fact is that if you don't have Secure Boot enabled, someone could actually have a laptop or even a smartphone set up and ready to go and could reflash the firmware on your device in less than 2 minutes if you weren't paying attention. As opposed to someone who was trying to glitch the device, they would not only have to know that you had it, they'd have to take it, they would have to disassemble it, glitch it for hours and hours, and then manage to reassemble it intact and slip it back into your possession without you noticing. Absolutely not something that someone's just going to do in like 2 minutes. All right, and the last thing I'm going to show you is how you apply firmware updates once you have enabled Secure Boot, in that the process is slightly different once you've done that, and you'll need to use one of the scripts that comes with the repository. So basically we just update the GitHub repository, that'll pull down any changes, and then we'll just build the firmware. Okay, and by default, that's going to give us a signed firmware file in the build folder called jade.bin. So what we do to flash that is we just use this Python tool that is included in the repository called Jade OTA. And we're just going to use the argument no agent because we don't want to use Bluetooth. We've just got this connected just by USB. And now I just hit enter. And we've just got to unlock the device. And there you go, and you can see this screen we get over here on the device is very much like the one you get on a retail Jade when you do a firmware update through the Green app. So you can actually see the versions, and you can also view the full hash of it if you want to as well. So we'll just say yes, we want to continue with the update. And there we go. So that device is now running the updated firmware. Summary time. Now, the first thing that I need to say, and this is something I'll repeat in the video that I do later on the retail Jade, is that I think the Blockstream Jade really sets the standard for what an open source hardware wallet can be, particularly one that's being sold through retail. It's one thing to have the source code available for your device. It's another thing entirely to have the hardware and schematics and those sort of details available. But to make it so easy to simply be able to grab off the shelf hardware and to be able to flash the software yourself is an incredible achievement as far as I'm concerned. One of the other things that's been really apparent with the Jade is that, for the other open source and DIY hardware solutions I've looked at, it's not really a cheaper way to get a hardware wallet. But that is simply not the case with the Jade. The fact that I can pay 10 USD for a fully functional, albeit, wired hardware device, or 20 USD for a fully portable Bluetooth battery powered one with no assembly, nice case, the whole shebang, that is something totally new in the space. So there you go. I've had a lot of fun with this, and it's also given me a really good insight as to how the Jade actually does things, the security model, and those other sorts of things that'll all feed into a video that I do on the retail Jade that'll come later. But for now, I'd really love to know if you're someone who's had a dabble trying to flash your own Jade, if you're someone maybe who has some sort of the different hardware configurations you might have tried, or even some strange differences within what should be the same hardware that I was using here. If you have any questions about the process, or you try it and you're running into any issues, just leave a reply in the comments. I do my best to answer all of them. Thanks for watching. I hope that was helpful. Hit like if you think that other people would find this video useful, and hit subscribe if you'd like to be kept in the loop about future content I make that helps people stay safe in the crypto space and to recover if they get into trouble. If you have any questions about this video or a topic that you'd like me to cover, just leave a reply.